All right, this is the PowerPoint on density. If you have any questions or comments or clarifications, let me know tomorrow. We'll do some examples and stuff like that in class and practice. So density is called a derived unit, which means it comes from two different measurements. The first measurement is mass, which can be grams, kilograms, pounds, ounces, things you measure mass in. And volume, which should be milliliters, liters, centimeters cubed, fluid ounces. And the equation for density comes from the mass divided by the volume, or in short, D equals M over V. M for mass, V for volume. So what is density? Density is a physical property of substances, compounds, and elements, molecules that describe how much mass in grams can fit in a certain volume, 1 milliliter. For example, water's density is 1 gram per milliliter, which means if you had 1 milliliter of water, it would mass out at 1 gram. Or if you had 1 gram of water, it would mass out at 1 milliliter. It would be a volume of 1 milliliter. Water. Other substances. Air is very low in density. That's good. It's at very low. It's 0.13 gram per centimeter cubed. Metals are larger than 1, so they sink in water. You can see here aluminum is 2.7, lead is 11.3, gold is 19.3. So for gold, if you had 19.3 grams, its volume would be 1 milliliter, or 1 centimeter cubed. Wood is less than 1. See here, oak is 0.85. That means it would float in water, which wood floats in water. All right, how do we calculate density? As mentioned before, the equation for density is mass over volume, M over V. So you need two things to calculate density. You need its mass in grams and volume in milliliters or centimeters cubed. It could be either one because 1 milliliter equals 1 centimeter cubed. So you need to make sure mass is in grams, volume in milliliters or centimeters cubed. Example A. A sample of aluminum is measured to have a mass of 4.56 grams and a volume of 1.69 milliliters. Determine the density of aluminum. So, using the formula M over V, we have the mass, 4.56 grams, divided by the volume, 1.69 milliliters. Plug that into your calculator, and you get 2.70 grams per milliliter. Example B. A sample of an unknown metal is measured to have a mass of 9.78 grams and a volume of 0.507 milliliters. It is believed to be gold, which has a density of 19.3 grams per milliliter. So the question is the sample gold? So we need to prove that if it is gold, it should have the same density of gold, which is 19.3. So use the equation for density, mass over volume, 9.78 grams divided by 0.507 milliliters. Plug in your calculator, you get 19.3 grams per milliliter. So densities match. Therefore, gold, bling bling, is your sample. Yay. Alright, last example. Sample C. Example C. A sample of silver metal is measured to have a volume of 5.89 milliliters. But uh-oh, you have no scale. You know the density of silver is 10.49 grams per milliliter. What is the mass of your sample? So, we don't know the grams. That's a question mark. But we do know the volume of 5.89 milliliters, and we know the density to be 10.49. So to solve this problem, we do have to do some cross multiplying. So we make 10.49 a fraction. So you put a 1 underneath it. And we cross multiply. 5.89 times 10.49 equal to x times 1, because x is an unknown. We don't know it. It's a question mark. So you multiply the two numbers, 10.49 and 5.89, and we get 61.8 grams equals x. So the mass of the silver is 61.8 grams. Alright, that is it. Homework's done. If you have any questions, let me know tomorrow. And